Hello my dear students, welcome back to the session. In the last class, we discussed up to 15th problem. Now let us look at quickly on 16th problem. 16th problem was asked in IES. I think we stopped in the middle of this problem, okay, in the last session. But quickly let us complete it. So we already discussed the data. What was the data given actually? R is equal to 20 ohm and it's an RLC circuit. It's an RLC series circuit, okay. And angle, that current lags behind the voltage by 45 degrees, and the voltage across the inductor is twice the voltage across the capacitor. So he's just expecting what is the value of VR. Clear? So from this we know that what is the value of XL is asking, right? Okay, XL is asking. From this we know that XL is equal to what? 2 times XC. This is equation 1. And angle is given RLC series circuit. You also know that tan phi, that is tan 45 is equal to XL minus XC by R. R how much here? 20. So from this I can say XL minus XC is equal to 20. Second. Substitute this XC value in this. Okay. So XL minus XL by 2 is equal to 20. From this XL can be given as 40 ohm. Okay. So options are given. Option C is correct. Okay. So this was actually, I stopped in the middle. Now let's go with the 17th question. Okay. So 17th question, let me read it. In an AC series RLC circuit, the voltage across RL is 20 volt. The voltage across LNC is 9 volt. And voltage across RLC is 15 volt. Then what is the voltage across C? Okay. So let me just note on the data given. VRL is given how much here? 20 volt. And VLC is given how much? 9 volt. VRLC is given how much here? 15 volt. So he is expecting what is VC value. Clear? So from this you understand that VRL is nothing but VR square plus VL square. Yes or no? 20 volt. So let's take it as equation 1. From this we understand VL minus VC is equal to 9 volt. And from this we understand root VR square plus VL minus VC whole square is equal to 50. Equation 3. It's very clear that if you substitute 2 in 3, okay, you get VR. Yes or no? VR. I can tell you the answer directly here. Please note down that value should be 12 volt. And substitute now VR in equation 1. Then you will get VL. Yes or no? So what is VL? 20 square minus VR square and square root. So once you substitute that here, you will get 16 volt. Now substitute this VL in equation 2. What do you get? You will get VC. That is nothing but 16 minus 9. That is 7 volt. Clear? This is how you can do from the data given. So it's all the relations we have discussed in case of RLC series and parallel circuits. Right? So you can use the same thing. Okay, quickly note down. This also, the question came in engineering service exam. Here also it was asked in IES. Clear all of you? So quickly note down. I just discuss the 18th question. Note down quickly. Hope you have finished that. Do that. Meanwhile, I just note down the circuit here. 18th one. There was an voltage source, AC source, 50 cos omega t. And the question was, the circuit was given like this, right? First capacitor, then inductor. Okay, both are same, but let me draw it again. Now 5 millifarad and 20 millihenry, and this is V0. So what is the question actually is asking? What value of omega will cause the forced response V naught in the figure to be 0? So V naught to be 0, okay, what must be the value of omega? So what is V naught 0? V naught 0 means voltage 0. Voltage 0 refers to short circuit. And you know that this is XC, this is XL. Now both are in series. The result is what? XL minus XC or XC minus XL. And voltage 0 refers to short circuit. That means it must be short circuit. That means its ohmic value must be 0. That means XL minus XC must be 0. That's it. So V naught 0 refers to short circuit. Okay, that means XL minus XC must be 0. That means XL is equal to what? XC. That means omega L is equal to what? 1 by omega C. From this we understand omega is equal to 1 by root LC. If you substitute that in this, okay, if you substitute that in this, root 5 millihenry, 5 into 10 power minus 3 into 20, 5 millifarad and 20 millihenry, 20 into 10 power minus 3. You will get 100 radian per second. Okay, finish that, all of you. Let's move on to another problem. Quickly move that, complete that. Meanwhile, I just note down another problem. So simple problems, you can easily do them. In AC circuits, you can easily handle the problems. But one must be good at calculations, I'm telling you. Complex numbers calculations are very, very important. You must be good at operating the calculator also. Okay. 19th question I'm just noting down. You complete that. Meanwhile, I just note down the circuit here. RC series circuit, RL series circuit, 3 Henry plus minus V, 1 by 2, 12 farad. This is 4 ohm and this is 8 ohm, and here it is given I, and this one given as 50 cos 40. Okay, it's just asking find I of t and V of t. That's it. That means he's asking the response in time domain. Okay. See, whenever an AC circuit is given, remember all of you, whenever an AC circuit is given, first of all, you need to convert that circuit. Whenever an AC circuit is given, first of all, you convert that into complex form or phasor form. Understand? You can't deal with the problem in the time domain. Some few cases can be handled, but let us not take any risk. All the time, better we have a common practice that we convert into what? Complex or sign, phasor form. So you know that already. What could be the values of this L and C in complex form? Let me write clearly here. This is nothing but what? JXL, right? J omega L. Omega value is how much here? J 4 into this is 3, that is J12. J12 ohm. Yes or no? Now coming here, minus JXC. That means minus J by omega C. That means minus, what is omega actually here? 4. And C is how much here? 1 by 12. So 1 by 12, okay, into 4. Then you got minus J3 ohm. Clear all of? So I just converted farads into ohms and henries into ohms. Now it's very clear that I can get I is equal to, this is I, right? This is the total voltage. And what about the complex form of this? 50 at an angle of 0. Some textbooks they take 50 by root 2. And some textbooks they follow only 50. Okay, but remember when you take 50, that means you are not dividing it by root 2. This is maximum value. So maximum to maximum phasor you are taking. Then phasor to sinusoid also when you take, you must be taking the maximum value as it is. Some people take RMS value, 50 by root 2. That means they converted maximum to root 2. I mean maximum to RMS value. Once they find the phasor, then when they come back to sinusoid, they multiply it by root 2 to get the maximum value. So it is up to you how you deal with, but I am taking in this context 50 by root 2. Okay, let me see what will happen here. So what is this V by? Okay, say this is Z1. What is Z1 actually here? Z1 is 4 minus J3. Okay. What is Z2? This is Z2. This is Z2 and this is what? Z1. Okay. What is Z2? Z2 is 8 plus J12. I hope you understand this. Okay. 8 plus J12. You have Z1 is 4 minus J3 and 8 plus J12. Okay. So very clear, I is equal to, what is I? This voltage by impedance. So 50 at an angle of 0 by Z1, 4 minus J3. Okay. You also know that this is in polar form. Let me write it clearly. It's 5 at an angle of minus 36.86. This is in polar form. 14.42 at an angle of 56.30. Polar form. I'm writing the impedance here. So what you get here, if you simplify this part, let me write it clearly. 10 at an angle of, okay, 36.86 amperes. But what do you want? You require I of t. Yes or no? What is I of t? Okay. Now this is maximum or RMS value? Maximum only. I of t requires maximum only. Therefore, I take 10 only. Now you started with the cosine, right? You started your conversion from cosine. Then go back to cosine same. Okay. So cosine 4t plus 36.86. And what is V? V is nothing but the total voltage is 50 at an angle of 0 between these 2 points. Say this is some Z2 dash, this is Z2 double dash. Then what is voltage across Z2 double dash? Z2 double dash by Z2 dash plus Z2 double dash. Voltage division rule. You can apply even for, okay, complex or AC circuits. Now, what is that value actually here? J12 by 8 plus J12 into, what is that voltage that you applied? So 50 at an angle of 0. This value will be, okay, 41.6 at an angle of, okay, you get 33.69. I give you the answer directly here, but you must be good at calculator operation as I told you already. Understand all of you, okay? So once you get this is the maximum value because you started your journey with maximum value only. 50 at an angle of 0, where 50 is the maximum value of the sinusoid. So again you get V of t is equal to 41.6 cos 4t plus 33.69. So this is how you deal with the problems in general. I've taken a simple example, but this is applicable elsewhere when you deal with sinusoidal problems or problems with the sinusoidal excitation, okay, under steady state conditions. Now, you can also think like this, because you know this I is nothing but V by Z, okay, but Z has a magnitude as well as phase angle, and V is in the numerator, Z is in the denominator, Z1, right? Z1 in the denominator. Z1 is having magnitude and also phase angle. V is also having magnitude and phase angle. Look at this. This magnitude is how much actually here? 5. What is the magnitude of the voltage? Because V by Z1, you already know that in the complex form. And once you come, convert again, reverse back, you know that this magnitude divided by this magnitude, you will get 10, 50 by 5, 10. And this angle 0, but Z1 is in the denominator, it has some negative angle, but when it comes to numerator, what will happen? It gets positive value. Yes or no? So therefore, 50 by 5, that is nothing but 10. Look at this. And cosine of 4t, that is 0 angle, 0 minus 36.86. So minus of minus 36.86, nothing but you got it. So sometimes you can skip this part. With some experience, you can directly put the answer. Okay. Now coming to this one also, you know that the magnitude, when you deal with the magnitude, the denominator deals with 14.42, the denominator actually, at an angle of 56.36. But when it comes to numerator, definitely you know that it has some negative value. Yes or no? And you know that J12, actually J is what? 90 degrees, 1 at an angle of 90 degrees. And into 50 at an angle of 0. So you know that it has 12 by magnitude of this directly, that is 12 by 14.42 into 50 at an angle of 0 minus 56.30 plus 90 degrees because J is there. So like that also you can analyze the circuits easily. Understand all of you, okay? But anyway, this is what the standard procedure to be followed, okay? So please note down that quickly. 20th problem I can go with. You just note down. Meanwhile, I just note down the problem here. Another problem. If I naught is 2 at an angle of 0, then Vs is how much? And what is Vs? This is what the circuit given. Okay. This is 1 ohm minus J1 ohm. And this is what I naught actually shown in the circuit. If you finish that, then read the question 20th one. Minus J2 ohm and 2 ohm. And is expected to find here, it is expected to find Vs value. Okay. I think you have finished this part, right? So let me remove this. Okay. I think you understand that network. All of you read out the network in your notebook quickly. You can note down that. Right. So what is asking actually here? It's a very simple problem. If you understand the data given clearly, what is I naught given actually 2 at an angle of 0? Okay, clear? Then what is the value of Vs is asking? See, you know that this is completely replaced by a single equivalent impedance or not? Yes, I can do. This can be replaced by a single equivalent impedance or not? Yes, I can do. Because these two are in series then parallel. But with this information, what you can do is, you can find the voltage across this 1 minus J1 or not? Yes. And voltage between these two, is it not same as voltage between these two? Because the 1 minus J1 is parallel to what? J2. So therefore, let me find the voltage across. Okay. This is, let us say, J2 ohm. Now the voltage between these 2 points, based on this current direction, I can say this is plus minus. Understand? Okay. I can say this plus minus. Say this is some V1. Assume that it is V1. Then what is V1 actually here? V1 is equal to 1 minus J1 into 2 at an angle of 0. So what is that value? 2 minus J2. Clear all of you? Okay. Now, let me replace, because the voltage between these 2 points is also same as what voltage between these 2 points. The same voltage will appear here. Now let me replace this entire one by Z2. And let me replace this entire one by Z1. Yes or no? Finally, it looks like this. Plus minus. Plus minus. You have Vs. This is Z1. This is Z. Oh, this is Z2, right? This is Z2. This is Z1. But you already know the voltage between these 2 points. How much here? V1. Okay. So there are 2 impedances. You know one impedance voltage across it. Then what is the total voltage asking? Let us apply voltage division rule. But when you apply voltage division rule, what could be the polarities division? Plus minus means this is plus minus. This is also plus minus. But the actual polarities are plus minus. But the desired polarities are what? Reverse to that. Therefore, you get a negative sign. Therefore, V1 can be written as Z1 by Z1 plus Z2 into Vs, but negative sign. Because there is a mismatch between the polarities here, right? So what you get here is Z1, but let me find what is Z2 here. What is Z1 here? Okay. What is Z1 actually? Let me find first. Okay. Z1 is nothing but, okay, 1 minus J1 parallel to J2. Z2 is nothing but, okay, 2 minus J2 parallel J4. Understand all of you? Okay. So what is 1 minus J1 parallel J2? 1 minus J1 into J2 by 1 minus J1 plus J2. Clear all of you? Okay. So what do you get here? It is nothing but you get here J2. Okay, what do you get? 1 minus, this is J2, J square is minus 1, that means plus 1, 2 into 1, 2 by. What do you get here? 1 minus J1 plus J1, that means 1 plus J1. So 1 plus J1, 2 plus J2, nothing but what? 2 times it will be cancelled, right? Similarly, you observe that 1 minus J1, 2 minus J2, J2 and J4, exactly double the value you will get here, that is 4 ohm. So this is 2 ohm. Once you substitute these values here, then V1, already you know what is the value of V1, how much here? If you substitute Z1 and Z2 in equation 1, in 1, then you will get 2 minus J2 is equal to, what is Z1? 2 by, what is Z2? 2 plus 4. So what is Vs actually? Okay, you need to find that. So finally Vs will be, this is 2, 3 ja, 3 2 ja, 6 minus J6 and minus sign. So minus of 6 minus J6. You know that minus, 6 root 2 at an angle of 45. And you know that 6 root 2, minus 45, right? Minus 45. Minus 45. Because 6 minus J6. So 6 root 2 will become 180 degrees. Minus 1 is nothing but what? 1 at an angle of 180 degrees. 180 minus 45, 135 degrees. This is what you get the answer. Quickly note down. So you have to be very good in the calculation. Can't do mistakes in the exam. I'm telling you, numerical mistakes. Many students are doing and losing the ranks. Okay, be careful. 21. Meanwhile, I just note another problem. Please complete that. Another problem. Two millihenry, 1 microfarad, 50 kilo radian per second is the frequency given. I think you finished this part, right? Hope you have done this part. Let me remove this. You can complete that. You can complete that. So to practice many problems in the material given by us in standard books, solve the problems as many as possible. If you see the history of any complex exam, particularly GATE and engineering services, most of the questions were given in DC circuits, AC circuits, transient analysis. Most of the questions. Okay, the other chapters also questions are coming, but a large number of questions are given in all these 3 chapters only. Okay, so coming to that, now he is expecting the value of Z in input impedance. So you know that when there is a dependent source, okay, so here it is given actually. Please quick note down this. I think in the circuit given, yeah, plus minus V. Okay, is also given. When dependent source problems are given, I told you already in DC circuits, when you want to find impedance, old time method is the only option or best option to find the impedance across the given terminals. Yes or no? I already explained that, right? So therefore, if I do that, okay, let me remove this also. If I apply old time method, here, but before you apply old time method, make sure that all values are in ohms. So this is in time domain, right? Again, convert into complex. So JXL, J omega L. So what is J omega L actually here? Omega is 50 kiloradian per second, 2 millihenry. So 50 into 10 power 3, 2 into 10 power minus 3. So cancel, and 100 ohm. So J 100 ohm is a value. And here is minus J by omega C. So minus J by 1 microfarad, 10 power minus 6 is the C value. Omega is how much? 50 kiloradian per second plus 3, right? So what do you get here? So you get, this is actually, you see 10 power 3. So minus J 10 power 3, that is 1000 by 50. It cancels, minus J 20 ohm. Clear? So if you apply the old time technique, say this is V dash, this is I dash, okay, capital V. Now this is also capital V, V dash, and this also become capital V because we converted everything into what? Complex. Now, when you apply old time technique, so what you get here, it's a single loop and you have a voltage source. Directly you can take V dash is equal to, what you get V dash is equal to 50 I dash. I'm just using touching concept, plus J, because the polarities will become, because of this current, plus minus only. Here also this is plus minus. You're touching positive sign first. So minus plus J100 into I dash plus 2V plus of but minus J20 into I dash. This is equation 1. But you need to eliminate V from this so that you can express V dash is equal to something into I dash, and that something is nothing but Zn, right? So substitute here, V is equal to 50 into I dash. So 2 in 1, you get V dash is equal to 50 I dash, clear? Plus J100 I dash, okay? Plus 2 times, that is 100, that is 100 I dash minus J20 I dash. So just add all the real values here, 150, and you add these two here, you get plus 80. So finally you get V dash is equal to 150 plus J80 I dash. This is nothing but what? Zn. Clear? Note on this 21 problem. Let's go for 22 later. First you finish that. Meanwhile, I just note down that circuit diagram here. Okay. This is what the network given. This is 10 ohm plus minus Vx, 4 minus J13 ohm, and this is 3 ohm, J4 ohm, 5 ohm, 20 at an angle of 90 degrees volts. So just asking Vx value. What is Vx? That's a question. Clear, all of you? So read the question clearly. 22nd question in the classroom workbook. You are expected to find Vx value. Now before we solve the network, you make sure that the entire circuit is in complex form. So already complex form. Otherwise you need to convert, just like what we had experience in the previous problems. 21st problem, 20th problem, we have seen already, right? We need to convert that. Frequency will be given. Based on that, you can convert. But already in the complex form, it is given, right? And is also expecting that complex value. Okay. Usually, we call them RMS values. All are RMS values. Okay. 20 at an angle of 90 degrees. Now, coming to the Vx value here. So, you need to actually, I think when the circuit is given, single source network, you can solve either using current division or voltage division. You can find the total current, I. Total current is nothing but total voltage by total impedance. And this current is divided again into two parts. This is Z1 completely. This is Z2 completely. So current through Z2, okay, is nothing but Z1 by Z1 plus Z2 into the total current. And once you get that current into this 10 ohm will give you what? Vx. This is usually the procedure. No doubt that you can apply, because single source network, you can apply current division or voltage division, doesn't matter. Or else you can apply voltage to total. This is Z1. The total you calculate is Z2. And first you find voltage plus Z2. Then again go back and replace the original circuit like this and divide this voltage, okay, among these two. Treating this one as Z1 and this one as Z2. Again you apply voltage division rule. But instead of that, let me go with the node analysis directly. Okay, because I'm good at node analysis. So 1 by 5. So 1 by 3 plus J4 plus 1 by 4 minus J13 plus 10. That means 14 minus J13. I hope you understand this. Okay, what is this total value? Total value is nothing but 14 minus J13. Clear? Is equal to 20 at an angle of 90 by 5 ohm. From this you find V value. I give you the answer directly, but you need to calculate it. That value is 10.544, okay, minus 70.858. So once you know this V value, can't you divide the voltage again, treating these two as this is Z1, this is Z2. So what is Vx then? Vx is nothing but Z2 by, that means 10 by 10 plus, what is that? 4 minus J13 into V value. How much V actually here? 10.544 at an angle of minus 70.858. So you calculate this and finish that value. That Vx value is supposed to be 5.519 at an angle of minus 28 degrees volts. That's it. Clear all of you? Okay. This is how you deal with the problem. Okay. You can go with directly what? Node analysis. Clear? Note on that. Meanwhile, I just take another problem here. 23. I just note another problem. Let's take another problem here. This is 12 ohm. This is J6 ohm. This is 4 ohm. This is plus minus 10 at an angle of 45 degrees volts, minus J3 ohm, 3 at an angle of 0 ampere. The question is, what is V1 and V2? Okay, I think you finished this previous problem, right? Yes. Let me remove it. Okay. So I think all of you remember when we solved DC circuits, multiple problems we solved, right? N number of problems we solved. I told you already, when there is a multi-source network, you must deal with always either mesh analysis or node analysis. Usually we prefer node analysis, and he's also asking node voltage here. If you go for mesh analysis, 1, 2, 3, 4 loops, 4 minus 1. Okay, 1, 2, 3, 4, 4 loops, 4 minus 1, 3 equations required. If you go for node analysis, 1, 2, 3, 3 nodes, but don't come to a conclusion unless you just check whether there is any voltage source without any series resistor. Yes, there is a voltage source without any series resistor. In this case, the 3 nodes, 2 equations, that particular condition fails. Yes or no? It all depends on the selection of reference node. Now, if I select any one of these 2 nodes as a reference node, say this is 0, this becomes what? 10 at an angle of 45. This becomes V. One equation is enough. Yes or no, all of you? I think node analysis is the best method to solve, and minimum number of equations required is of what? 1 to solve the network, to analyze the network. So let me just temporarily convert this into, okay, these are the 3 nodes, right? You have, just I'm writing here. If I take this one is 0, then what will I get here? 10 at an angle of 45, and this becomes what? V. So now this is V, this is V, and this is 0. Yes or no? Now this becomes what? 10 at an angle of 45. Temporarily I am just dealing with the problem here by taking this node as a reference node. I'll come back again by taking the 0. What is V1, V2? I can come back. I can go for that conversion later on here. Okay. So once I solve for V, what will happen? I just take this is 0. Then what will happen to V1 here? 10 at an angle of 45 minus V. Yes or no? Because this becomes 0 means you are reducing this voltage by V. Then every node voltage is reduced by the same voltage V. So 10 at an angle of 45 minus V. Taking this 0, then definitely you call it V1. You already defined that initially. Then V2 becomes 0 minus V. That means minus of this voltage. Yes or no? So let's find what is V here. So V of, let me use again, V minus 10 at an angle of 45 by minus J3 plus 3 at an angle of 0, V by J6, V by 12. But I'm using inspection here. 1 by minus J3. Okay, 1 by minus J3. 1 by J6. 1 by 12 is equal to, that is leaving current. Usually leaving current in inspection, it is 0 outside. And you also don't neglect this, right? Here 10 at an angle of 45 by 10 at an angle of 45 by 45 by, this is minus J3. So solve for the value of V. Once you get V, then what is V1 you know, what is V2 you know, according to this particular conversion. Yes or no, all of you, okay? So it's very easy to deal with the problem with a single equation, yes or no? So let me tell you what is V value here. Minus 31.4 at an angle of, okay, that is minus 87.18, or else you got 31.4 at an angle of 92.82. This is what the answer you got for V. But what is V1? 10 at an angle of 45, okay, minus 31.4 at an angle of 92.82. Its value is supposed to be, I can give you what is V1, 25.78. Please do the calculation using your calculator. Keeping the calculator in the complex mode, you can do it. I already solved all these things on my own, I'm telling you. So you also please check the answers. You're supposed to get these values. So 0 minus, okay, minus 31.4 at an angle of 92.82. Finally, you'll get 31.4 at an angle of minus 87.18. Clear, all of you, okay? So this is what the answer for the given question. Any circuit given in AC circuits, okay, better you solve using node analysis. Most of them can be solved easily. 99% of the problem can be solved using node analysis. Do that all of you quickly. Note down. Twenty-fourth problem. Three J4 and the voltage is given as V is equal to 100 at an angle of 30 degrees. Okay. Determine power triangle. Power triangle means what? What is the power triangle? You have power triangle with active power, reactive power, apparent power, and the phase angle, right? Phi. So all of them let's try to find here, okay? So I think you have noted on this, right? Okay. Now, power triangle can be determined in different ways. When impedance and voltage is given, method one, this is a standard method. S is equal to V into I conjugate. But you know that V value is given, but I need to be found here, V by Z. That is 100 at an angle of 30 by 3 plus J4. Clear? 100 at an angle of 30 by, you can calculate this in the polar form, 5 at an angle of 53.130. So finally you got that current value, 20 at an angle of minus 23.130. Clear, all of you, okay? If you substitute these values, voltage and current in this, S is equal to magnitude V, okay? V at an angle of 30, so that's 100 at an angle of 30, and conjugate of current is nothing but what? 20 at an angle of, when you take conjugate, it becomes what? Plus, right? 23.130. So 2000 at an angle of 53.130 volt ampere. So the real part of it, the real part is nothing but 2000 cos 53.130. Imaginary part is what? Plus J to 2053 point sine 53.130. So finally you get 1200 plus J 1600. You can calculate that volt ampere. So this is nothing but active power. This is nothing but what? Reactive power. This is P. This is QL. I can say because it is an inductive reactive power. Yes or no? So what is the angle difference between the voltage and current? This is what the voltage phase angle difference between voltage and current. So phi can be written as 53.130. So this is the power triangle, you can say. So this is P, this is QL, this is S, this is angle phi. All the values are known here. Method 2, you can find in a different way that when you know current I is equal to, already you found that V by Z, how much it is? 20 at an angle of minus 23.130. You require just RMS magnitude to find the active power. Okay, the active power or average power or true power or real power are same. Okay, I told you already they're all synonyms of active power. So active power is magnitude of I square into, that is 320 square into IR square R. I told you already. In this case, I and IR both are same because it's a series circuit. Okay, so therefore 20 square into 3, you will get again 1200 watts. Yes or no? QL will also be like IL square XL. What is XL? 4. So 20 square into 4, 1600. Okay, volt amp reactive. Okay. So depending upon the situation, you can apply the formulas. You can go to that formula, you can go for this formula. Okay, as are all of you. Some people use, P is method 3. Okay, method 3 can be written as, some people use P is equal to VI cos phi. First they find V phasor and I phasor, then VI cos phi they can use. Okay, because we are going to see some problems. Depending upon the data given, we are supposed to apply any one of these formulas. Okay, depending on the situation, we have to proceed. Now, what is that V actually 100? What is that I actually here 20? What is the cos phi? Cos phi is the angle difference between the voltage and current. How much it is actually here? Voltage phasor is 30 degrees. Current phasor is minus 23.130. The difference is 30 minus of minus, that is 53 point cos 53.130, and finally you will get 1200 watts. QL is VI sin phi. VI sin phi. Okay, so it's very clear, 100 into 20 into sine 53.130, you will get now 1600 volt amp reactive. Clear all of you? Method 4 you can use. There are many methods actually you can use. See, that is a series circuit, right? That's a series circuit. Can I divide the voltage here? Say this is VR, this is VL, because active power and reactive power can also be defined as VR square by R, reactive power VL square by L. Yes or no? IR square R or VR square by R. I told you already that formula. So let me find that VR, but I deal with only RMS magnitude. Directly I can find 3 by, that is R by Z into V. Because I'm dealing with only magnitude. Because power formula requires only RMS magnitude of that either IR or VR. That's it. So that is why I'm dealing with RMS magnitude. Or else complex, if I want to find VR is equal to R by R plus JXL into V I can write. But I want only magnitude. What is the T by? What is the magnitude of it? Root 3 square plus 4 square. What is that magnitude? 100 only, right? So what will I get here? This is 5, 520 ja. So finally I got 60 volt. So what is the P is nothing but VR square by R. Understand? VR square by R. So 60 square by 3. You understand? 60 square by 3. So 3 2 ja 20 into again 60. It's again 1200 watt. QL is nothing but VL I want, right? So what is VL? VL is nothing but, so don't take VL is equal to V minus VR. No. VL mod is not equal to V mod minus VR, right? Magnitude you cannot deal like that. So again you need to find what is that XL by magnitude Z into V. Finally you got 4 by, this is 5 into 100. So you got 520 ja and you got 80 volt. So VL square by XL, 80 square by, what is XL value here? 4, right? So what do you get here? 1600 volt amp reactive. Once you know active reactive, you can find S value. Clear all of you? Okay. So this is how many ways are there, many formulas are there. Just to make you understand, I've given all these things, but you can use any one of these. But remember, in the problems, you're getting different varieties of problems to use this power formula. But all of you must be good at in applying all these formulas, because it's giving different contexts where sometimes that formula will work out, where sometimes this formula may work, sometimes this formula may work, like that, depending on the situation. You have to proceed. Please note down quickly. I just remove this part, okay? You note down all the, I think you have noted on this part, right? Then you proceed with that. Meanwhile, I just remove this part, okay? I take another problem, 25th. Meanwhile, just note down all those things. Meanwhile, I just write another problem here. 25th problem. It's also very important. Hope you have finished, all of you. Okay, I think you understand that, right? Now let's go with another 25th problem. Let me read that problem here. A two-element series circuit has a power of 940 watt and a power factor of 0.707 leading. If the applied voltage V is equal to 99 sine 6000 t plus 30 degrees, determine the circuit constants. Clear? So 25th problem. The data given here is asking circuit constants. That means either RC or RL. But what is given? 0.707 leading. And he said only two element circuit. That means definitely it must be what? RC, yes or no? But active power is given how much? 940 watt. Because watts are given, right? So therefore I can call it an active power or average power. And the power factor was given cos phi. Power factor is how much? 0.707 leading. Leading means it is definitely what? RC circuit. Because he said only two elements. And two elements means definitely it must be either RC only, right? Okay, understand all of you? Then what is V given? 99 sine 6000 t plus 30 degrees. He is asking what is the circuit constant. That means he is asking what is R value, what is C value. Clear all of you? Well, so to find R and C value, probably I think you require the voltage and current, yes or no? But if you know voltage and current, probably you can find easily the impedance. Once you know impedance, real part and imaginary part you can separate. Real part is nothing but R, imaginary part is nothing but XC. Once you know XC, you know the frequency, you can find C. Clear? So from this, the data given, the power formula, which formula is more suitable to find I? To find I, active power, voltage and current relationship, what do you have? P can be written as IR square R. P can be written as VR square by R. P can be written as VI cos phi. In this context, to find I, VI cos phi is more suitable. That means this kind of formula is more suitable. So therefore, P is equal to VI. V is nothing but what? 99 by root 2. Okay, let me write first the formula here. Okay, VI cos phi. Better I remove this part. Okay. Remove this part. P is equal to VI cos phi. What is V? Tell me all of you. Is it maximum value or RMS value? Definitely RMS value. Okay. So therefore 99 by root 2 into I into cos phi. How much here? 0.707. What is this value? 940. Then you can find I value. Understand? So what is the I value you got? 19 amperes. 19 amperes. If you just simplify it, you will get 19 amperes. Okay. Now voltage phasor is known, right? What is the voltage phasor actually? You can write voltage is equal to 99 at an angle of 30 or 99 by root 2 at an angle of 30. If you write 99 at an angle of 30, that means you are taking only maximum value here in the phasor representation. If you take 99 by root 2, that means you are taking RMS value in the phasor representation. So if I take now, what is this actually? Is it RMS value or maximum value? RMS value. If you take this is RMS value, better you take here also RMS value. And my suggestion is always to avoid the confusions. Better you deal with RMS values. Understand all of you, okay? So that there is no confusion, there is no calculation mistakes, I'm telling you. So I can be written as what now? 19. Since current leads voltage by how much here? How much here? This angle is how much actually? Phi is equal to how much? Cos inverse 0.707 will give you 45 degrees. Yes or no? That means current leads voltage by 45 degrees. When current leads voltage by 45 degrees, then already voltage is having 30 degrees. So 30 plus 45, that means 75. Now you get it. Then once you know voltage and current, you know that RMS voltage by RMS current will give you 19 by 9 by root 2 by 19 at an angle of, that's why I told you here, you're taking the ratio. If one is expressed in maximum, the other is expressed in RMS, how can you take the ratio? That is why you must take RMS value. So better you remember always sine to RMS or cosine to RMS phasor. Understand all of you, okay? Now what do you get here? 30 minus, because here at an angle of what? This is at an angle of 30, this is at an angle of 45. So 30 minus leading, right? Sorry, 75. This is how much here? 75. So 30 minus 75, you get it. Okay. So 99 by root 2 by 19. This is nothing but minus 45. Okay. So you get Z value 3.684 at an angle of minus 45. You will get 2.606 minus J 2.606 ohm, because 45 degrees, the real part and imaginary part both are same. So this value is R and this value is how much? XC. What is XC? So XC is nothing but 2.606. XC is nothing but 1 by omega C. Yes or no? Is nothing but 2.606. But C is equal to 1 by omega how much? 6000 into 2.606. You can get C value. I can give you 63.95 microfarad. This is how you are supposed to solve the problem. Okay, so note down that, all of you. Okay, so 25 problems. I mean, we finished. We have some more problems. We have around 40 plus. Okay, we will see the next coming problems. Okay.